to maths. We're doing, your presenter today is not able to make it today, so I will take over and I'm going to take you through symmetry and 2D and 3D shapes to show you how it works. I hope you have an interesting time. If you have any questions, then you can raise your hand and I will explain it to you slowly. Okay, so lines of symmetry. Basically, what you need to know about symmetry is that it's a reflection. And if you put your hands together, like say, when the Christians pray, they have their two hands together. Now, if you open your hands, it's basically symmetrical. So symmetry is a reflection of the identical half of the opposite side. And the line of symmetry basically means that you are drawing a line going straight down. It's basically a dotted line. I'll show it to you as we go along. But first, to recap what a 2D shape is, basically a 2D shape is a two-dimensional flat shape where the length and the width have no thickness. Okay, so this is basically the length and this is where the width is. Now the 2D shape has three characteristics. It has a vertex, which is here. Then it has a side, which are all these four sides, the length and the width. And then it has an angle. So the angles are the corners inside. Okay, so a vertex, if they ask you name it's one vertex but many vertices. Vertices are the plural for excuse me, the corners, and it's plural for vertex. So in the text, if they ask you name the vertices, how many vertices does the shape have? So you look at the shape and you count all the corners. So a vertex is basically where two lines meet. So this is one line and this is another line. So this corner here is a vertex and it is where these two lines meet. Then we have sides. The sides are these lines here. So can you see the lines that make the shape? This is a rectangle. So your sides are, the line segments are the sides of a polygon. So this is a four-sided polygon. I request that you keep your cameras off. We're not sharing cameras. Okay, so your sides depends on the object. If it is like a square or a rectangle or a straight-sided polygon, polygon is a closed-sided figure. Any figure that it has is closed. It's enclosed. Okay, so if we have a polygon that is straight, then we say that the lines are straight. But now if we have a sphere, or then we say that the lines are curved. Okay, so the angle in this right angle is at 90 degrees. And also in a square, the angle inside where the two lines meet is basically at 90 degrees. And it is the angle that gives us a certain shape. So for example, this rectangle, because the angle here is at 90 degrees here, it basically means that the lines are perpendicular. So it gives you the shape of the rectangle. The only difference between a rectangle and a square is that in a rectangle, the opposite sides are equal, and here the opposite sides, and in a square, all the sides are equal. So to recap, we say a vertex is where two sides of the polygon meet. Then a side, the side is a line segment, are the sides of the polygon. It can be straight or it can be curved. And then the angle is a rectangle and a square at 90 degrees. And it is the angle that gives the shape, that gives the shape a certain shape, it gives it its shape. So just a revision of what polygons are. So you need to know that polygons are an enclosed shape. Enclosed shape meaning that you can see that all these shapes here are closed. All the lines meet. So they meet at their vertices. So it's not an open shape. So we have an equilateral triangle. It has 3 lines here, and it has 3 vertexes. Okay, so 2D shapes are very easy to check the vertexes and the sides. It's more complicated as you go along in 3D shapes. In 3D shapes, you need to look at the flat shape when they ask you to name an object. So whatever the flat shape, the flat face is, it gives the name of the object. Like in this case, you have an equilateral triangle. It has 3 sides. Now a square has 4 equal sides. Then we have a pentagon. This is a regular pentagon. It has 5 sides. And how many vertexes? So it's 1, 2, 3, 4, 5. And if they ask you how many lines does it have? It's 1 line, 2 lines, 3 lines, 4 lines, 5 lines. Then we have a regular hexagon. So a hexagon is a 6, it has 6 sides. There's 1, 2, 3, 4, 5, 6. So in your test, it's actually better to mark them off so you don't get confused as the number of sides get bigger. And how many vertexes you have? That's 1, 2, 3, 4, 5, 6. Okay, and if we're going to do a regular heptagon, so there's 1, 2, 3, 4, 5, 6, 7. Heptagon is a 7-sided figure, and it's regular. Okay, because it's an enclosed shape and it's fixed. Then we have a regular polygon. It has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. So let's see how many vertexes does it have. It's 1, 2, 3, 4, 5, 6, 7, 8. So basically also you can do opposites. 2, 4, 6, 8, 10, 12, 14, 16. So let's see if that's true. 1, 2, 3, 4, 5, 6, 7, 8. So why I said 2 was 1 here, 1 here. So it's actually 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 vertexes. So then you have a nanogon. A nanogon is a 9-sided figure. So because it's 9 sides, so you know there's nine sides in it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many vertexes? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the fact that this basically the name of the shape, you know it's nanogon 9 sides, decagon 10 sides, deocanon it's 12 sides. So however, depends on the name of the shape. If you know what the name of the shape is, you already know how many sides it has and how many vertexes it has. So one of the ways to look at, we have hepta. Hepta means 7. So it's 1, 2, 3, 4, 5, 6, 7, because it has 7 corners and 7 sides. Then octagon. Octagon comes from octa. It has 8 sides. So you have 8 corners and 8 sides. And then you have decagon. Decagon comes from decade, deca, that's meaning 10. So it has 10 corners and 10 sides. So you can use this information for when you have to calculate it for 3D shapes. Because remember, in a 3D shape, you have opposites. So let's say you have this octagon for instance. You know it has 2 flat sides, the opposite ends. So if it's 8 and 8 on the other side, that's 16. Then all you'd have to do is, I'm going to try and put my highlighter on, and because it will help. I hope nothing happens. Okay, so it's working now. So let's say we have your 3D shape where you're going to go out like this. So obviously this flat shape is going to connect to another flat shape just like this, flat face just like this, and you get your 3D shape. So if it's 8 here, then on the side, on this flat space here, it's going to be 8. And then all you do is count the lines all around it. So it's 1 line, 2 lines. Then it would be 3 lines, 4 lines, 5, 6, 7, 8. So it's 8 lines extending it out to meet the other flat shape like that. So it's 8 plus 8 plus 8 gives you 24 lines. So that's how it sides. So that's how you can calculate your sides for a 3D shape. So recapping on angles, so you know what angles are and how they can give you your shape. So you have a right angle here. The correct uh, uh, line for a right angle, the measurement when you're going to show is not this curved line here. It's actually a line like this. Yes, Tando, you have a question? I'll ask my host to unmute you. Okay, while he's going to unmute you, I'll continue. So you have an angle, which is a right angle. So that's the correct way to draw a right angle to show you that it's a right angle. So an acute angle is basically less than 90 degrees. An obtuse angle is basically, it goes over 90 degrees. So if you look at the angle here, the right angle, an acute angle will be any angle that is in between the 90 degrees, any part from here to here. Then the obtuse angle goes over the 90 degrees. So it will be like that. Then we have a reflex angle. So your reflex angle is basically if you have your right angle here, so your reflex goes down. It goes over 180 degrees. It goes over a straight line. So this is basically your right angle showing the bottom part of it. And then you have your acute angle showing you it showing this way as well. And then you have a straight line. So a straight line has its center here, and it means that it is 180 degrees. That's the point. So this is how they show you a reflex angle if you're going to calculate it in your test. And they can show it to you in different ways. An obtuse angle. They basically put it in different ways when they want to test you. And you use your you take your measurements doing this here. Okay, so now we're going to move on to basically symmetry. A symmetry or an object is symmetrical when it can be divided into two parts. That is a mirror image of the other. So the lines that divide the shape or the object into two or match equal halves or two matching halves is basically called your line of symmetry. And some shapes have only one line of symmetry and other shapes have many lines of symmetry. Like, for example, before I take you to what symmetry is, I'll show it to you here on this here. So like this triangle, it doesn't only have one line of symmetry. So it has one line here, it has one line here, and one line here. It has three lines of symmetry. And the square, it can go down this way, down that way, and then it can go also from one end to the other end here, and also from one end to the other end here. Okay, so that's basically, you must know that it must open into equal halves. So no matter what the shape is, before I continue, like it's not going to be very straight, this drawing, and it's obviously not going to be symmetrical, but it's not symmetrical at all. But you draw a line of symmetry like this. Okay, so this shape is not symmetrical at all. I'm just showing you, and you'll see it more clearly in the pictures that you have over here. So you have an equilateral triangle here on the top, and an equilateral triangle, the fact that it tells you it is equilateral, it means that it has three lines of symmetry. Equilateral tells you that all the three lines are equal. So when you draw your lines of symmetry, it is one going down, then one going from this end to the middle of the line. So when you're drawing your lines of symmetry, you have to use your ruler. And when you use your ruler, you measure from 0 to whatever the line ends, measure what half is, and then from one point right to the middle, you you construct a straight line. You do it that way. Also here, you take your ruler, you measure from 0 to whatever it ends here, then you measure half, put a dot here, then from this tip going out of the diagram, a straight line joining to where that dot is, and you go out of the diagram. Your line of symmetry must go from outside to outside. Must never just be from inside to inside. Because if you do that, they will mark it wrong in your test. So it has to be from out to out. Then for this side, what you do as well, you start with your measurement from your ruler 0, and you measure to this half, to the end here, you measure half. Then from one point, and you draw your line, dotted line, extending outwards. You must use a ruler. You cannot do it freehand, because if you do it, you're going to draw it like how I did it in the previous slide, and you could see that it was not symmetrical at all. The drawing was not symmetrical, and neither was the line of symmetry. It was not straight. So the importance of using the ruler. So if you had to draw it like how I did freehand in your test, they will mark it wrong. You must use a ruler like this. So then we have, now these are also all regular polygons. So we have a square. A square has 4 lines of symmetry. Always use your ruler to measure half. You get your point at half, mark it. Then you measure this ruler here, get your point of half, mark it here. Then take your ruler and you draw a straight dotted line going from outside of the diagram to this part outside of the diagram. And you do it for all these sides. That shows you if you're going to measure half. Now the cool thing about a square is, because all sides are equal, where the vertex is here and here, you're going to draw a straight line, dotted line going across the shape. Because if you look at it, this half here is basically equal to that half. If you had to fold it in half, if you had to draw it and you folded it in half, you would see that this overlaps with that. And you can do the same thing with the side. From this point here, where the 2 lines meet, and that 2 lines, you go straight and you draw your line. So no matter what you do, even if you can take a page when after this lesson, and you can draw a square, then you can cut it up and fold the square into halves, as many ways that you can, and you'll see the lines of symmetries that it has. Tando, I'll ask my host to unmute you. You have a question? Okay, so I'll continue until you get unmuted. So if we're going to look at this regular polygon here, pentagon here, pentagon, why? Because it has 5 sides. So that's 1 side, 2 sides, 3 sides, 4 sides, and 5 sides. So a regular pentagon, what they did here is from this tip, they used a ruler. Always use the ruler from 0 till see what it ends, measure half, and from this tip to that half, and you draw a straight dotted line down this way. So if you look at this diagram here, you can see at all the points. So this point here, I'm going to draw it above here. This point here, this point here, this point here, this point here, and this point here. So let's use this. From this point, they measured half here and they drew a line of symmetry. So from each point on the opposite side, you measure half of the line. You put your dot where the half is here, and then you take your ruler and you draw a dotted line going from out to out. So one more time, here's your dot here. You measure half of this line here, you put a dot here, and then you take your ruler and you draw your dotted line. Because if you do that, all your lines will intersect at the middle. That's how you know that it will be correct. Okay, so you have your hexagon. Your hexagon is 6 sides. And how to remember hexagon has 6 sides. So you remember x here, SIX is 6, so hexagon is 6 sides. So you do the same thing for the lines of symmetry for the hexagon. So except for here, when you drawing from this line, you draw half of the line connected, draw your line. But when you have these dots here, like when you're just drawing the dots, you can just draw your lines of symmetry across the 2 dots. So a hexagon has 6 lines of symmetry. And also don't forget the lines in between. Here, where you can draw your lines. So if you memorize this by heart and you learn it well, that means that you know that equilateral triangle, 3 lines of symmetry. A square, 4 lines of symmetry. Pentagon, 5 lines of symmetry. Hexagon, 6 lines of symmetry. If you just remember this well and memorize it, so if it has to come out in the test, you don't have to think about it, you'll know it for sure, and then you just have to draw the lines. That's one of the, it would become an automatic process, so you'd learn it well, and then you can take that time that they normally give you to allocate to think and to draw it. You can take that extra time and use it for more difficult sums that are a bit more challenging and require more time. So memorization for these are a good technique to help you save time and concentrate on sums that are more difficult in your exam. So we have an irregular polygon. So an irregular polygon here is basically a shape that doesn't is irregular in the sense that it doesn't have fixed sides. Like you had a hexagon, it had six equal lines. You had a pentagon, it had 5 equal lines. You had a square, it had 4 equal lines. You had a heptagon, all the lines were equal. So an irregular polygon is where you have these shapes and it has, even though it can be 1, 2, 3, 4, 5, 6, 7, 8, it has 8 sides. It doesn't have a fixed shape like a octagon would have. Okay, so this is a line of symmetry here. And this here on this M, the line of symmetry, because if you had to fold the M in half, you could see that it would meet exactly, like how your hands are folded, you'll have it together next to each other, all meeting. So your M will meet like that. And the same with the arrow. So the one that is not symmetrical, which one is not symmetrical? It is this one. Because if you had to fold it, it's not going to meet exactly. Okay, if we had to take this side here and you had to fold it over, you would see it would not meet the side here. Okay, it would go over somewhere over here. So this one here is not symmetrical. So if you had to do this in your test, it would be marked wrong. And these ones here would be correct. Okay. So you have homework. Your homework, you would draw 3 regular polygons and 2 irregular polygons. So remember those regular polygons I showed you, and I showed you irregular polygons. And then I want you to draw lines of symmetry to show that the lines meet. They are 2 equal halves. You can draw any lines of symmetry. Practice the ones that I showed you where you had lots of lines of symmetry, so you get that practice for the irregular polygons. And then your regular polygons will basically only have 1 line of symmetry. Okay, so today basically you learned that about lines of symmetry, and then you also recapped on what regular polygons were, 2D shapes, and you also learned the vertexes and the edges, how to differentiate between the two. So remember, the lines of the symmetry are the lines that divide the shape of the object into two or matching halves, or equal parts. Okay. And tomorrow you're going to do division, and your teacher would be back. If you'd like to contact her, it is abonkolo@gmail.com. And I hope that you enjoyed this lesson, and we'll see you here tomorrow at the same time. Okay, goodbye and have a lovely day. I hope this lesson was beneficial for you.